Hello everyone. Welcome to the first session of Diode. This is the basic electronic tutorial series of dr-bios.com. I intend to present the basic concepts of diode. I'll start by telling you the definition of a diode. Diode is an electronic component with two sides, which conducts electric current in one direction and shows high resistance in the other direction against current flow. The resistance is ideally infinite. Diode has different types and shapes. I'll talk about some of them in the following. As you see, this is the symbol of diode. The positive side is anode, and the negative side is cathode. To be able to know how a diode works, I have analyzed its function at the end of this video. And in case you like to learn more about the concept, please keep watching. As I said, diode conducts current in one direction and shows high resistance in the other direction against current flow. If you place the diode in a direction that it can pass current, exactly as you see in the picture, we say that the diode is placed in forward bias. And in this case, diode shows very low resistance. Another thing I need to mention is that most diodes have a line on one side, like the one on the picture, which indicates that it is the negative or cathode side. And what does forward bias mean? It means that conventional current enters from the positive side, and it exits through the negative side. In this way, we simulate the diode of a circuit to a closed key, as you see in the picture. I should mention some points here. To start electrical conductivity on this circuit, diode needs voltage, which is called threshold voltage, which is something between 0.4 volt and 0.6 volt in normal diodes. And the voltage value depends on the type of impurity used in diodes. And it is approximate. And as you see, if you change the direction of a diode on a circuit, current won't flow through the circuit. In this way, we simulate the diode of the circuit to an open key. But I should say that very low current passes through the diode. But we ignore that low value where we use the diode. Let me show you forward and reverse bias on a circuit. I used a light-emitting diode on this circuit and controlled the extra voltage by using a resistor, and used a diode on this circuit and applied voltage to the circuit by using a 9-volt battery. As you see, diode is in forward bias, and that's why the LED is on. I'll remove the diode now and place it reversely. Yes, as you see, by placing the diode reversely,
با قرار دادن دیود در جهت معکوس
current doesn't flow through the circuit, and LED turns off. And this means diode is in reverse bias
غیر مستقیم قرار داره
and acts like a closed key. Now I'll talk about the usages of diode and start with half-wave rectification. As you know, utility power is AC,
به صورت AC هست.
and when current is in positive half cycle,
ما در نیم سیکل مثبت خودمون قرار داریم.
the diode on the rectification circuit lets current pass through it,
جریان را از خودش عبور میده.
and the output voltage will be same as input voltage.
ولتاژ معادل ولتاژ ورودی خواهیم داشت.
But in negative half cycle,
در نیم سیکل منفی قرار داریم.
as this diode doesn't conduct current,
قسمت قرار داره. جریانی را از خودش عبور نمیده.
and it is in fact in reverse bias, output voltage is zero. To show this concept in a more detailed way, as you see in the picture, in positive half cycle, output voltage equals the input voltage, and in negative half cycle, no current will flow through the circuit. As you see, in this way, output signal is only 50% of the input signal. This means there is 50% waste, which we don't want this to happen. So there are other recommended designs which I'll talk about in the following. Now I'll practically show the things I theoretically explained on previous slide. I used a 220 volt to 12 volt step down transformer and transferred its output to the breadboard and made a rectification circuit using a diode and a load resistor. My oscilloscope has two channels. The yellow channel on the bottom is 12 volt output of transformers AC, which I transferred to the oscilloscope directly. And the cyan channel on the top is circuit's output after rectification. And as you see, output signal is only 50% of the input signal. As I mentioned on the previous slide, half-wave rectification has 50% loss, and 50% of the input signal can't be on the output. Therefore, we use full-wave rectification, for which we need to use a three-phase transformer. If you're not familiar with the mechanism of this type of transformer, I'll fully analyze it on the next videos. On the positive half cycle of this rectifier, the first diode conducts current and lets the current pass through it. And second diode acts as an open key and doesn't conduct current. As polarity of input AC changes on the negative half cycle, the second diode conducts current, and the first diode acts as an open key and doesn't conduct current. The advantage of rectification is that there is no energy loss like previous situation, but the disadvantage is that using a three-phase transformer costs so much, and it's practically not economical. Therefore, we use some other designs such as Diode Bridge. And since this design is so complicated and non-practical, I'm not going to talk more about it. I only wanted to point out this kind of design. Another commonly used design on rectification circuits is Diode Bridge, which is made of 4 diodes that converts alternating current to direct current. When input signal, which is AC signal, is on its positive half cycle.
یا نیم سیکل مثبت خودش قرار داره.
Diode 1 and Diode 3 conduct current,
سوم جریان رو از خودشون عبور میدن.
and as Diode 4 and Diode 2 are in reverse bias,
دلیل اینکه در بایاس غیر مستقیم قرار دارن
can't conduct
جریان رو
current.
از خودشون عبور بدن.
That's why there is positive signal on the output.
خروجی سیگنال مثبت خواهیم داشت.
And in negative half cycle,
ما در نیم سیکل منفی هستیم.
as AC polarity changes, current passes through D4 and D2.
جریان از D4 و D2 عبور میکنه.
And in this way, as D4 and D2 are in forward bias,
دیود شماره 4 و دیود شماره 2 در بایاس مستقیم هستند.
they conduct current.
عبور میدن و
And as Diode 1 and Diode 3 are in reverse bias, they can't conduct current. The thing I need to mention about this picture is that the resistor inside Diode Bridge is the load resistor, and I placed it here to show and explain current flow in a better way. Which is load resistor of Diode Bridge. And you can't see this resistor on Diode Bridge designs. I only put it here to be able to explain in a better way. Let's talk about Diode Bridge function now. As you see, this is positive half cycle. And in positive half cycle, current passes through D1 and then load, and after that D3. And output signal is positive. And in negative half cycle, current passes through D4 and then load, and after that D2. And output signal is positive in this way as well. I should say that positive and negative half cycles occur continuously, but I showed them separately, as I wanted to analyze the function in positive and negative half cycles in a better way. I should say that diode bridges are commonly used, and almost all power circuits and adapters use them. And they convert the output signal that you can see here to a DC voltage with the help of an inductor and a capacitor, which I'll talk more about on the next videos. I put a diode bridge circuit on a breadboard and used a step-down transformer to apply 12 AC voltage to diode bridge input and show its output on the oscilloscope. As you see, the image on the oscilloscope is exactly like the picture on previous slide, and that is the signal. In order for you to get familiar with diode bridge function, I'll remove one of them from the circuit. As you see on the output, and as one of the half cycles won't be there after removing the diode, whether it is positive or negative half cycle, the output will be 50% of the input. And by placing back the diode, we can see that the signal is back to its initial shape. As diode bridges are commonly used, instead of using 4 separated diodes in circuits, they use a diode bridge package that contains 4 diodes inside it. But as you see, it's not something strange. They are only 4 diodes placed in a package. They have different types that you can see in the picture. In this section, I'm going to test diode bridge package. The first thing to keep in mind, AC pins shouldn't be connected to each other. I'll check them now. And as you see, multimeter doesn't show any number. To test diode, I'll place black probe on positive DC and check one by one. In this way, one of the diodes is the conductive, and the number that appears is between 0.4 and 0.6. I should say that the number is approximate. I'll place the probe on another AC pin. And in this way, current passes through a diode as well. And by placing it on negative of DC, the number is almost twice of the previous value. And it's because in this way, current passes through two diodes. I'll reverse the probes. I place red probe on positive of DC. And now, diode should not show any value in any of the ways. And it acts like an open key on the circuit. I'll place red probe on negative of DC. And black probe is on AC. And again, current passes through one of the diodes. And in this way, it passes through another diode. And when I place black probe on positive DC, exactly like the previous test, it passes through two diodes in this way. And the number is twice of the previous value. I reverse the probes again. And place black probe on negative of DC. And no number should appear on both ways. One of the usages of diode bridge is making backlight tester, for which you need a diode bridge package. As you see, I connected two wires to DC output and used a high wattage resistor to control current value. And isolated it for protection by connecting the tester to power. By observing safety precaution for checking the effective voltage. 220 volts should be displayed on the multimeter, which is the effective voltage that this tester shows. And by using this simple circuit, you can convert AC voltage to DC voltage. But I should say that the DC voltage on the output isn't completely smooth. But the voltage is an effective voltage. On the previous slide, I showed you how to make backlight tester as one of the usages of diode bridge. Now I'll briefly talk about how to use it. A very important thing you need to keep in mind is that you need to observe safety precaution while making and using this kind of testers, as their input and output voltage is 220 volt, because otherwise it can cause irreparable damages for your health. Let's test backlight now. I'll apply voltage to the circuit. And as you see, there is a burned LED on this line. I'll check the second line. There is a burned LED on this line too. Let's check the third line. And there is no burned LED on this line. Another usage of diode is clipping voltage. And if you want to cut the voltage, you need to place a direct current supplier in series with the diode. As you see, there is an input signal here, which is AC. It enters the circuit. And there is a diode here which is in forward bias. And after that, there is a direct current supplier. Voltage value of this DC supplier is called bias voltage, which shouldn't be higher than maxima of input sign voltage. That based on bias voltage value, or the voltage of this direct current supplier, we see that the output signal is cut. You might wonder what the usage of the clipper is. which is used on some circuits to protect electronic components which are usually transistors, as those components are sensitive, and to control those circuits so that voltage won't go upper than a certain point, and in order for them not to burn, they use voltage clippers. And the circuit I showed you on this slide is a very basic form of voltage clipper. On this section, I implanted previous voltage clipper on this breadboard and used a step-down transformer to apply 12 AC volt to the circuit, and used power supply to control bias voltage, and use power supply to show the effect of increasing and decreasing bias voltage on the output signal. As you see, when bias voltage changes, the cutting measure changes as well, and the change is completely visible here. A very commonly used type of diodes is Zener Diode, which is used as voltage stabilizer. And as you see, it is placed in reverse bias on the circuit. This is Zener Diode shape, but it has other shapes as well. This black ring indicates cathode or negative side, and the other side is anode or positive side. And this is the symbol of Zener Diode. And its difference from other diodes is this broken part in the beginning and the end of this line. The importance of Zener diodes is that how much voltage they can handle. Because when applied voltage to both sides of Zener diode, when the diode is placed in reverse bias on the circuit, as you see in the picture, goes upper than a certain point which we call Zener voltage. In this way, diode will conduct current. Zener voltage is also called breakdown voltage. To make this concept a bit easier to understand, have a look at this circuit. Let's assume we use a Zener diode with 13-volt Zener voltage, which is called 13-volt Zener diode. If the applied voltage to the circuit is lower than 13 volt, for example if it is 10 volt or 9 volt, diode won't conduct current as it is in reverse bias at that point. But the difference between Zener diode and the rest of diodes is that when voltage gets higher than 13 volt, diode conducts current. Now let's say the voltage gets higher than 13 volt and reaches 14 volt or 15 volt. In that way, the output would still stay around 13 volt. This is why one of the important usages of Zener diode is stabilizing voltage. But Zener diodes can tolerate voltage increase to a certain point. And if input voltage goes upper than a certain point, the diode will burn. For example, I have a 13-volt Zener diode, and I increase the input voltage up to 19 volt. The Zener diode might not tolerate voltages more than 19 volt. You can easily refer to the diode datasheet to check its tolerance. To make things easier to understand, I have implanted the circuit of the previous slide on a breadboard and used a power supply to apply input voltage to the circuit. and use two multimeters to measure voltage of two sides of the diode and the resistor.
سر دیود و مقاومت رو اندازه میگیریم.
The red multimeter is to measure voltage of two sides of diode,
سر دیود
and the blue multimeter is to measure voltage of two sides of resistor.
یه ولتاژ دو سر مقاومت هست و
This number is the error percentage of power supply, Zener Diode or probably multimeter.
هستش که منبع تغذیه دیود زنر و احتمالاً مولتیمترمون داره.
This is a 13-volt Zener diode.
دیود زنر 13 ولتی هست.
All gradually increase the applied voltage to the circuit.
رو افزایش میدیم.
All increase it to around 4.2 volt.
4.2 ولت افزایش میدیم.
As you see, voltage of two sides of diode is 4.2 volt now,
دو سر دیود 4.2 ولت است.
and voltage is absent on both sides of the resistor.
ولتاژی رو از خودش نشون نمیده.
What's the reason? It's because diode is in reverse bias now and it doesn't conduct current,
جریانی رو از خودش عبور نمیده.
and it acts like an open key. And this is why voltage doesn't enter either sides of resistor,
سر مقاومت ولتاژی نمیرسه.
meaning current doesn't pass through the circuit, therefore voltage can't enter two sides of resistor. All increase the voltage and set it on 10 volt. In this way, around 10.7 volt is present on two sides of diode. I repeat that the difference is because of error percentage, and voltage is still absent on resistor, because the diode is acting normally at this moment too. And as it is in reverse bias, it doesn't conduct any current. Let me increase the voltage up to 13.5 volt. As you see, voltage of both sides of the diode is 13 volt now. And the extra voltage, which is around 0.5 volt, will be applied to resistor. And now if I parallelize the load or voltage consumer with Zener diode, a voltage that equals 13 volt will be applied to it. While when voltage is lower than 13 volt, no voltage will be applied to the resistor. I'll increase the voltage again. And as you see, voltage of both sides of diode is stable. And the rest of the voltage is applied to two sides of resistor. This is why we use Zener diode as voltage stabilizer. Because as you see, by increasing the voltage that's present on two sides of Zener diode gets stable. There is another type of diode which is called Shotkey Diode. They are used in high current. And one of the mostly used types is double Shotkey Diode, which is used in transformer output of power circuits. This is the symbol of Schottky Diode. And its difference from simple diodes is this additional part in the beginning and the end of this line. Now let me show you double Schottky Diode schematic. Current enters through pins 1 and 3 and exits through pin 2. Let me show you current entrance on the actual diode as well. As you see, current enters through pins 1 and 3 and exits through pin 2. To test double Schottky diode, you need to go according to the schematic drawn on the diode. It's like you test two diodes separately. I place black probe on pin in the middle and place red probe on pin 1 first. 0.1 to 0.4 needs to appear on multimeter on diode mode.
بین 1 دهم تا 4 دهم باشه.
I should say that it's an approximate value,
شما عرض می‌کنم عدد تقریبی هست.
and I'm saying it based on experience, and it can differ a bit,
درصد این عدد بالا و پایین باشه.
but this is the approximate value to indicate that a diode is okay.
اوکی بودن هست همین هول و هوش هست.
I'll remove the red probe from pin 1 and test pin 3. The value needs to be approximately like before in this way too. I reverse the probes now. I place red probe on pin in the middle and place black probe on pin 1 first. In this way, no number should appear on the multimeter. For the third pin as well, which means that the double Schottky diode is working. As I said, double Schottky diodes are usually used on power circuits, and they are placed after transformer output. To test double Schottky diode on circuits, first you need to find it, which is placed on the second heatsink. I'll turn over the board and place black probe on pin in the middle of double Schottky diode, and place red probe on pin 1 first. Around 0.1 needs to appear on multimeter in this way. Then I remove red probe from pin 1 and place it on pin 3. Around 0.1 needs to appear in this way too. These values are approximate and is related to the condition of the rest of the components on board. But if you see these values, you can make sure Schottky diode is okay in 70% of the times. And to properly test the Schottky diode, you need to remove it from the circuit. Another type of most commonly used diodes is light-emitting diodes, also called LEDs, which are made of a thin layer of semiconductors that have more impurity than simple diodes. And depending on the type of impurity used in them, they emit colorful light with a particular spectral wavelength. You can see an LED in this picture, and another one. This LED is a single color LED, and as you see, it only has one direction for forward bias. This one is tricolor LED, and its mechanism is in a way that, by putting first LED on forward bias, it emits one color, and by putting this part on forward bias, it emits another color. And by turning on both of these LEDs, the two colors get mixed and it emits the third color. LED schematic is similar to diode schematic, but with a difference. Two arrows are pointing out, which means they emit light. Another usage of light-emitting diode is that they are used in 7 segments. 7 segments are made of 7 or 8 separated LEDs, and they show numbers from 0 to 9. Let's test some light-emitting diodes on the board. The first diode is slightly bigger than simple diodes. and has a resistor on its pin.
مقاومت هم تو پایه‌های خودش داره.
Therefore, there was no need to place a separated resistor to control voltage.
کنترل ولتاژ وجود نداشت.
I'll turn on the diode.
دیود رو روشن می‌کنیم و
Let's see how it is.
هست.
As you see, as it is bigger than simple diodes,
بزرگتری که نسبت به دیودهای عادی داره،
it emits brighter light.
هست.
I'll turn on the second and third single-color diodes with different colors.
متفاوت هست که یکی سبز رنگ هست و دیگری قرمز رنگ هست رو روشن می‌کنیم.
The different colors is because of the level of diode's impurity.
میزان ناخالصی هستش که توش استفاده شده و
And depending on the level of impurity, they emit different colors.
رو از خودشون ساطع می‌کنن.
I'll turn off the second diode. I'll turn on the next diode, which is tricolor LED. I'll turn on one of the diodes first. As you see, by turning on one diode, only one color will be emitted from this diode. Now I'll turn off this side and turn on the other side to show you the color difference. As you see, the color that diode emits is different from before. And by turning on these two diodes simultaneously, as you see, it emits a new color which is a mixture of those two colors. The next diode is a 7-color diode that can emit different colors. Yes, as you see, this is a 7-color diode. It can emit different colors by mixing them together and managing time. The next concept is optocoupler, which can be an IC or integrated circuit. Its main function is to isolate 2 points of circuit using light. For example, if you want to directly command a motor by a microcontroller, or activate relay on a circuit, it might cause noise when the motor gets activated, and might have a bad effect on the controller function and cause disturbance. This is why we use optocoupler. They are specifically used on power circuits, as the transformers that are used on power circuits create some noise. So we use optocoupler to get feedback from output voltages. This is the structure of an optocoupler. It is made of a light-emitting diode, and its right side is made of a transistor that its gate pin gets enabled by light. In this section, I'll use a simple circuit that contains an optocoupler to show you the usage of this electronic component. I connected pins 1 and 2 of optocoupler to voltage supplier. LED of optocoupler are connected to them, and connected pins 3 and 4 that are output of phototransistor to an LED. And applied voltage to LED using a separated voltage supplier, which is a 9-volt battery. What we expect from this circuit is that, by increasing value of the applied voltage to optocoupler LED, the light emitting from light-emitting diode needs to gradually increase. In other words, we need to have control over intensity of LED light. Please note that Pins 1 and 2 are completely isolated from pins 3 and 4 of optocoupler, and we control this by applying and changing voltage of LED pins that's inside optocoupler. All turn on the power supply and slowly increase its voltage. As you see, when voltage of power supply changes, LED light changes too. You can refer to its datasheet and check maximum and minimum voltage that can be applied to optocoupler. As I said, optocouplers are frequently used on switching power circuits, meaning there is at least one optocoupler on every switching power circuit. To test optocouplers on circuits, you can check primary block of optocoupler using a multimeter. I'm using a pen-type multimeter. Number appears on the multimeter on one way, but it shouldn't appear on the other way. All test an optocoupler outside of a circuit. But as this video is about diodes, I'll only test pins 1 and 2 that go to light-emitting diode of optocoupler. First, I'll test optocoupler in reverse bias using pin-type multimeter. No number should appear on this way. Yes, as you see, number doesn't appear. Now I test it in forward bias. Number appears, which means LED of the optocoupler is okay. I'll test a problematic optocoupler now. I test pins 1 and 2 in reverse bias, and number appears, which shouldn't appear on this way. All tested in forward bias too. Numbers appears on this way too. And as number appears on both biases. So diode of optocoupler is problematic, which means optocoupler is completely problematic and can't function properly on a circuit. Another type of diodes is SMD light diodes, which are used as status indicator LEDs on mainboards. Some of them are placed on a mini board outside of the mainboards, and some are placed on mainboards. To test these of diodes, you need to set multimeter on diode mode and test them in forward and reverse bias. Diode doesn't turn on now, and this means it's in reverse bias. I'll reverse the probes now, since multimeter applies voltage to it. Diode turns on, and that means SMD light diode is okay. I'll test a single Shotkey diode now. I'll set multimeter on diode mode and test the diode in forward bias first. As you see, 0.2 volt appears. And as it's a Schottky diode, it means that it's okay. I reverse the probes now. And in this way, either a big number needs to appear or no number. 1.4 volt appears now. And I can almost say that this diode is okay. And to test it properly, I need to test it outside the circuit. As shown on the schematic, I set multimeter on diode mode.
حالت تست دیود قرار میدیم.
First I place red probe on pin 3 and black probe on pin 1.
مشکی رو پایه 1 قرار میدم.
No number or a big number needs to appear now.
عدد بزرگی رو باید ببینیم.
No number appears on this way. I'll reverse the probes. I place black probe on pin 3 and red probe on pin 1.
اول قرار میدیم.
Diode acts like a conductor now, and between 0.4 volt to 0.6 volt appears now, which means diode is okay. I reverse the probes again.
دوباره جهت پراپا رو تغییر میدیم.
I place red probe on pin 3 and black probe on pin 2.
قرار میدیم.
Numbers shouldn't appear on either of the ways.
جهت معکوس نباید عددی رو ببینیم.
I set multimeter on diode mode,
دیود قرار میدیم.
and place red probe on pin 1 and black probe on pin 3.
انقلاب مشکی رو پایه سوم قرار میدیم.
Between 0.4 to 0.6 needs to appear in this way, and the reason is that this diode is in forward bias.
دیودی که در این قسمت شما مشاهده می‌فرمایید در بایاس مستقیم قرار گرفته.
And these values are approximate,
اینجا خدمتتون عرض می‌کنم اعداد تقریبی هست.
and they depend on so many factors.
زیادی بستگی داره.
Different values might appear in different situations.
بودن و یا معیوب بودن قطعه دیگه‌ای داخل
For example, if other components inside boards are problematic.
متفاوتی نمایش داده بشه.
I'll reverse the probes.
من تغییر میدم.
I place black probe on pin 1 and red probe on pin 3.
قرمز رو روی پایه سوم قرار میدیم.
Number shouldn't appear in this way,
نباید عددی رو مشاهده کنیم و
or the number needs to be big.
بزرگی باشه.
And as you see,
مشاهده می‌کنید
1.4 volt appears on multimeter,
4 دهم ولت رو نشون میده
which is a big number.
بزرگی هست.
Now I place red probe on pin 2 and black probe on pin 3.
انقلاب مشکی رو پایه سوم قرار میدیم.
No number appears in this way.
مشاهده می‌کنید ما عددی رو نمی‌بینیم.
I reverse the probes.
تغییر میدیم.
I place red probe on pin 3 and black probe on pin 2.
انقلاب مشکی رو پایه دوم قرار میدیم.
Between 0.4 and 0.6 appears in this way, which means this double Schottky diode is okay.
بودن این دیود شاتکی دوبل ما هست.
I tested one side of this Schottky diode first,
دیود شاتکی رو تست کردیم.
in forward and reverse bias.
بایاس مستقیم و بایاس غیر مستقیم.
Then by reversing probes, I tested this diode.
این یکی دیود رو تست کردیم.
And as both of them were working,
به دلیل سالم بودن دو تا دیود
we realized that this Schottky diode is okay.
اوکی هست.
I should say that, as I performed the tests on the circuit,
انجام بدیم.
I can make sure by 70% that the Schottky diode is okay.
شاتکی اوکی هست.
In order to test it properly,
تستش رو
you need to remove the component and test it outside the circuit.
کنیم و بیرون از مدار تست کنیم.
As you saw on previous slides,
قبل مشاهده کردیم
most double Schottky diodes that are used as SMD components on laptop circuits
در مدارات لپتاپ از اونها استفاده میشه.
are like one of these shapes.
این اشکالی هستش که شما اینجا مشاهده میکنید.
You can detect direction of diodes.
شماتیک اون لپتاپی که قصد بررسی
By referring to schematic of the laptop you intend to check.
تشخیص بدیم.
And according to the way I showed you on previous slides,
اسلایدهای قبل عنوان شد.
test the component in terms of health.
تست کنیم.
Let's go back to the concept and I'll explain how diodes work.
دیودها دقیقاً به چه شکل عمل میکنه.
As you know, materials divide into three categories, in terms of electrical conductivity level: non-conductor, conductor and semiconductor. And their electrical conductivity level is determined based on capacity layer. But what is capacity layer? To have a better understanding of this concept, let me introduce Na equals 2N2 formula. And explain the concept with some simple examples. I'll start with neon atom. It has atomic number 10, which means 10 electrons move around its core.
اطراف هسته اون گردش میکنن.
according to the formula.
فرمولی که بهتون ارائه دادیم
By
با
placing 1 in the formula,
گذاری عدد 1 در فرمول
meaning the first layer,
اول
we get
ما
2,
عدد 2 رو به دست میاریم.
meaning
در
2 out of
لایه
10
اول
electrons of neon atom go to the first layer.
تا الکترونی که اتم نئون داره میتونه بشینه.
What about the second layer?
لایه دوم
By placing 2 in this formula, we get 8,
بالا جایگذاری کنیم میرسیم به عدد 8
which exactly equals the remaining electrons.
تعداد الکترون‌های باقی مانده است.
What does it mean? It means there are 10 electrons. 2 electrons are on first layer, so there are 8 electrons left, and those 8 ones go to the second layer. And capacity layer will be completed. And this element is called nonconductor because it can't conduct any current in normal situations. And for the second example, I would like to talk about copper. That has atomic number 29. Let me explain the concept using the formula again. By placing 1 in the formula, we get 2, which means 2 electrons go to the first layer. There are 8 electrons on the second layer, and 18 electrons on the third layer, and 1 electron on the fourth layer, meaning there is an electron far away from the core. And that's why this element is called conductor. My last example includes silicon and germanium, which are used inside diodes. Silicon has atomic number 14, and germanium has atomic number 32. I'll explain with the formula again. There are 2 electrons on first layer of both these atoms, and 8 ones on the second layer, and 18 electrons on the third layer of germanium, while there are 4 electrons on the third layer of silicon, and 4 electrons on fourth layer of germanium. That's why it's called semiconductor. Number of electrons on capacity layer of nonconductor element is complete, and there is 1 electron on capacity layer of conductor element, which is far away from the core. And semiconductors are, as I said, in the following all define band gap, which is the required energy for electrons to be able to exit capacity layer. As you see, 8 electrons are on capacity layer of neon atom, and as they have a strong bond with core, it requires so much energy to release the electrons and exit capacity layer. As you see on the picture, there are 4 electrons on capacity layers of silicon and germanium, and the required energy for them to exit capacity layer is much less than what neon atom needs with 8 electrons on capacity layer. And there is only 1 electron on capacity layer of copper element, which is far from the core. That's why they need much less energy to exit capacity layer compared to 2 other types of elements. Atoms tend to complete electrons of their capacity layer. Imagine silicon atom that has 4 electrons on its capacity layer,
داره.
but it has the
اما
capacity to have 18 electrons on its capacity layer.
اتم سیلیکون 18 هست.
And because of
به
that
دلیل
tendency,
همون تمایلی که من خدمت شما عرض کردم،
silicon atom creates a bond with its neighboring silicon atoms.
در مجاورت خودش قرار داره پیوندی رو برقرار میکنه.
Therefore, they share electrons of each other's capacity layers.
خودشون رو با هم دیگه به اشتراک میذارن.
Have a look at this silicon atom.
سیلیکون رو در نظر بگیرید.
There comes another one.
یک اتم سیلیکون دیگه
And as you see, they share electrons with each other.
می‌بینید، به اشتراک میذارن.
It does the same thing with the other neighboring atom too.
همین کار رو انجام میده.
And this creates a bond between all the neighboring silicon atoms,
همه اتم‌های سیلیکونی که در مجاورت یکدیگه قرار میگیره
which is called covalent bond.
تحت عنوان پیوند کوالانسی نام میبریم.
In fact, electrons are firm on their places with this bond.
الکترون‌ها در جای خودشون مقید شدن.
Imagine an atom that has an electron on its capacity layer.
الکترون در لایه ظرفیت خودش داشته باشه.
By giving energy to the electron on the capacity layer,
لایه ظرفیت هست. انرژی مثل انرژی گرمایی بدیم.
the electron exits capacity layer and enters conduction layer,
و به لایه رسانایی وارد میشه.
which means electron becomes a free electron.
الکترون آزاد میشه.
The empty space of electron on capacity layer is called hole.
حفره میگیم.
Holes have positive electrical load,
حفره‌ها در واقع بار الکتریکی مثبتی دارن.
and electrons have negative electrical load.
الکتریکی منفی.
I repeat again, holes have positive electrical load,
حفره‌ها بار الکتریکی مثبت دارن.
and electrons have negative electrical load.
منفی.
Imagine a free electron
الکترون آزادی رو داشته باشیم.
that exits capacity layer by heat
گرما از لایه ظرفیت خارج شده و
and enters conduction layer. If the free electron finds a neighboring hole,
که یک حفره در مجاورت خودش پیدا کنه،
it goes and stays inside that hole.
حفره در واقع ساکن میشه.
As you see in the picture,
می‌بینید
electrons move and go towards holes.
و به سمت حفره‌ها میرن.
In fact, this is how
هستش که
electric current gets established in general.
الکتریکی در یک نیمه رسانه و به طور کلی جریان الکتریکی برقرار میشه.
In fact, the direction of electric current is towards the side I told you.
به این سمتی هستش که من خدمت شما عرض کردم.
But we consider current direction in the opposite of what I told you.
در شماتیک‌ها، در بوردها،
On designs, schematics, and boards.
به صورت معکوس این جهتی که خدمت شما عرض کردم در نظر میگیریم.
Meaning, we imagine that the holes are the ones that move
حرکت میکنن
and go to electrons.
میرن به سراغ الکترون‌ها.
This is called conventional current direction.
جریان قراردادی میگیم، اما
But the real current direction is the one I talked about.
که من خدمتتون عرض کردم.
Meaning, electrons are the ones that move. But we tend to believe that holes move.
حفره‌ها در حال حرکت هست.
So that was the definition of electrons and holes.
و حفره‌ها ارائه دادیم.
Now let's go back to this slide about covalent bond.
کوالانسی
Imagine silicon atoms that are in a firm covalent bond together.
کوالانسی محکمی با هم دیگه هست.
If one of these electrons exits its capacity layer
یکی از این الکترون‌ها از لایه ظرفیت
because of environment heat and becomes a free electron,
آزاد بشه،
the empty space of the free electron or hole will be filled by another free electron immediately.
آزاد یا اون حفره سریعاً با یک
Because there is a balance here,
پر میشه.
and as number of holes and free electrons is so insignificant in this combination,
توی این ترکیب بسیار ناچیز هست.
current flow will be so insignificant as well.
هم بسیار ناچیز خواهد بود.
As I said on the previous slide, silicon element has low electrical conductivity.
بسیار ناچیزی داره.
This is why we try to change its electrical conductivity level
کردن ناخالصی به ساختار کریستالی سیلیکون
by adding impurity to its crystal structure.
که اون رو تغییر بدیم.
One of the elements to add to silicon as an impurity is antimony.
سیلیکون اضافه کنیم آنتیموان هست.
Antimony has atomic number 51 and has 5 electrons on its capacity layer.
در لایه ظرفیت خودش داره.
And
و
because of that,
که در واقع 5 تا الکترون در لایه ظرفیت خودش داره،
if it gets in a covalent bond with silicon atoms,
های سیلیکون قرار بگیره، همونجوری که در تصویر مشاهده می‌کنید،
1 electron will be free.
آزاد میشه.
And as electrons increase in this combination,
اینکه الکترون‌های ما افزایش پیدا می‌کنه،
and as I said, that electron has negative electrical load,
الکترون دارای بار الکتریکی منفی هست،
a semiconductor will be created which is called N-type semiconductor,
درست میشه که ما اون رو نیمه هادی نوع N می‌نامیم.
because that semiconductor has negative electrical load,
منفی داره.
and N is the first letter of negative.
حرف نگاتیو به معنی منفی هست.
Let's talk about another element called boron,
در نظر بگیرید مثل بور
that has atomic number 5 and has 3 electrons on its capacity layer. When this element gets in a covalent bond with 4 silicon atoms,
پیوند کوالانسی برقرار کنه،
it leaves a hole,
در واقع حفره از خودش جای میذاره.
and as the number of holes increase in this semiconductor,
تعداد حفره ها افزایش پیدا میکنن.
it's called P-type semiconductor.
نوع P یا پوزیتیو گفته میشه.
As I said, N-type semiconductor has free electrons,
نوع N الکترون آزاد
and P-type semiconductor has holes.
P حفره داره.
By putting N-type and P-type semiconductors together,
و نیمه هادی نوع P
free electrons of N-type semiconductor
نیمه هادی نوع N هست،
move towards holes of P-type semiconductor,
نیمه هادی نوع P حرکت میکنه.
as you see in the picture.
تصویر مشاهده میکنید.
This action creates an electric field between N-type and P-type semiconductors,
نوع N و نیمه هادی نوع P ایجاد میشه.
which is called PN bond,
میگیم پیوند P و N.
and base of diode function as PN bond.
کار دیودها پیوند P و N هست.
Now imagine you connect positive pole of voltage supplier to P-type semiconductor,
به نیمه هادی نوع P
and its negative pole to N-type semiconductor.
نوع N متصل کنیم.
What happens is that the number of holes in P-type semiconductor will increase,
نوع P افزایش پیدا میکنه.
and on the other hand, number of electrons in N-type semiconductor will increase.
افزایش پیدا میکنه.
This increase causes current to be established in this semiconductor.
در این نیمه هادی برقرار بشه.
What happens is not exactly like this,
حالا دقیقاً به این شکل نیست، ولی
but in order to be able to imagine how diodes work,
به شکل ساده بتونیم تو ذهنمون تصور کنیم،
we can model it like this.
میتونیم عملکرد دیود رو مدل بکنیم.
But if we connect negative pole of voltage supplier
ما قطب منفی منبع ولتاژ رو به
to P-type semiconductor
نوع P متصل کنیم
and connect its positive pole to N-type semiconductor,
نوع N متصل کنیم،
current won't be established in PN bond.
پیوند P و N برقرار نمیشه.
And it's because electrons of negative pole
الکترون هایی که در قطب منفی هستن
go inside the holes and fill them.
این حفره ها میشینن و حفره ها رو پر میکنن.
And on the other hand, electrons of N-type semiconductor go and fill the holes of positive pole.
و حفره هایی که در واقع از قطب مثبت میاد رو پر میکنن.
And cause to amplify the electric field between these two bonds,
بین این دو تا پیوند هست میشه
and current won't flow.
نمیکنه.
I repeat again, the example was only for better understanding of diode function,
بهتر عملکرد دیود هست
and to see what actually happens and how electric field gets amplified.
چجوری در واقع این میدان الکتریکی تقویت میشه.
More detailed analysis is needed.
مفصل تری داره.
So this was the base of how diodes work.
خدمت شما عرض شد.
I wanted to explain it simply and also briefly.
مختصر و مفید عملکرد دیود رو تشریح کنیم.
And there is no need to analyze it in too professional way.
خیلی وارد بحث‌های تخصصی تر بشیم.
Thanks for watching.
از شما که تا انتهای این ویدیوی آموزشی با ما همراه بودید.
As you know, diode is very complicated,
دیود بحث بسیار پیچیده‌ای هست.
and tens of tutorial videos might not cover the whole concept.
مباحث اون رو به طور کامل پوشش بده.
So I try to
ما بر این بود
cover all important and basic concepts of diodes in a tutorial video.
تحت عنوان آموزش‌های الکترونیک پایه داره ارائه میشه
and present it as a concept in basic electronic field.
دیود رو پوشش بدیم.
So if you feel the need,
نیاز بشه
we will produce videos to teach you reading different diodes datasheets in the future.
رو در باب دیتا شیت خوانی انواع دیودها ادامه خواهیم داد.
Thanks again for your time.
از اینکه وقتتون رو در اختیار ما گذاشتین.
Please let us know your opinion about this video in the comments.
پیشنهادات خودتون رو در رابطه با این ویدیو با ما به اشتراک بذارید. با تشکر.